Hey YouTube, welcome to Second Revision. Today we'll be reading an NES controller with an Arduino. I think I left that over there. There it is. Here's our NES controller. To connect your NES controller to the Arduino, there's two ways you can go about it. You can either plug wires into the NES controller connector if you don't want to cut the cord, or you can cut the cord and we will show you which wire colors land to which pinouts on the Arduino. The NES controller actually only has one IC in it, and that is the 4021 shift register. So we have a row of 3 sockets and a row of 4 sockets. The top of the row of 3 sockets is the plus 5 volts. The top socket in the row of 4 is your 0 volt common. The one below common is going to be your clock signal. The one below the clock signal is your latch signal, and the very last is your data signal. This is where you're going to read the data from the controller. In our last video, we showed you how to solder 2 wires together. These were in fact the wires to our NES controller. Connecting the controller to the Arduino, we have chosen pin 2 to be the orange wire, which is our latch signal. We have chosen pin 3 for the yellow wire for our data input, and we have chosen pin 4 for the red wire for our clock signal. The color code for the NES controller wiring starts with the white wire. The white wire is our 5 volt power, so 5 VDC. Our common is the brown wire, 0 volts. Our next wire is the clock signal, which is our red wire. Our orange wire is our latch signal, and the data output is the yellow wire. We're also powering our controller from the Arduino board using the plus 5 volts and ground pins. We've gone and connected the NES controller to our Arduino using a breadboard. The breadboard is not necessary, but it makes it a lot easier for me to hook up the oscilloscope probes. The way the Arduino code works is that it continuously loops, repeating the same pattern over and over again. We're using this to our advantage to use what is called bit banging out clock signals. What this means is that we are sending out clock pulses. We're sending out a signal high, waiting for a period of time, and then sending out the signal low in a sequence over and over again. It's called bit banging because the cyclic nature of the program is not consistent. If we were to actually use a clock signal, we would have a lot more consistent clock pulses. This can be clearly seen on the oscilloscope when we unpause. The shifting nature of the oscilloscope is due to the bit banging in the program. There are 8 clock pulses. The pink one is just stretched, but if you look, the pink line is up for 1, and then we have 7 yellow pulses, and then this is the continuation of the pink line. So there's a total of 8 clock pulses in which we need to read our data. When our latch signal, the pink line, is high, the controller takes in all of the button presses simultaneously. When our latch signal goes low, it allows us to clock out each button press individually so that we can read it on our Arduino over one digital input. This teal line represents the data line. I'm going to go ahead and run the oscilloscope so that we can see some of the button presses. The reason that the data line drops from 5 volts to 0 volts is due to the fact that the NES controller represents a grounded signal as a true signal and a high signal as a false signal. So all of the button presses are actually coming back in as 1s on the Arduino code. When we go ahead and press a button, a 0 represents that the button has actually been pressed. The shift register outputs the button presses in the same order every single time. As you can see here, I have pressed the B button, and it will always show up on the first clock pulse. The select button, which is next, will always show up on the second clock pulse. The buttons will show up on the rising edge of their clock pulse. So you can think of this one as the B button clock pulse, the select button clock pulse, the start button clock pulse. The only button that is different is the A button. The A button is output immediately after our latch signal goes low. So we send our latch signal high, we read in every single button press, and then we bring our latch signal low, and the A button output is output immediately, whether it's been pressed or not been pressed. Thanks for watching our video. Go ahead and give it a thumbs up if you liked it. If you didn't, please tell us why in the comments. Also, click that subscribe button and click the bell to be notified about our new videos. Check out more of our content at Second Revision on Instagram.